Welcome back. My name is Anshu and this is my channel Bottleneck. This is a data structures and algorithms series. In this series, we are going to learn and implement data structures and algorithms using Scala Functional programming approach. In our previous video, we had seen Sudoku puzzle board. What is Sudoku puzzle and what are the constraints? We also implemented the default Sudoku board and two constants that we are going to use throughout this implementation. So one was the get box, which will return the index. With the given index, it will return the value of that box. All right, let me fix this spelling. All right, and we also saw another method that is going to return the value based on the Sudoku grid. All right, so we are going to use these two methods to implement the Sudoku puzzle solution. If you have missed out on my previous videos, I will share the link in the description. Also, a link to my GitHub page where you can find the solution for this whatever we have implemented this code. All right. So let's directly go to our implementation. So let's implement dev create Sudoku Sudoku board, or let's create Sudoku. It will start with temporary value. You can give it anything. It could be anything. And when you are trying with this temporary value, we want to give a random value, a random sequence or nil, anything you as you like. Now we will also have the accumulator. This is going to be our Sudoku. It is going to be sequence of int, and it is going to return a sequence of int. This is going to be a tail recursive function. All right. If our ACC list dot length equals to Sudoku grid star Sudoku grid, that is, if it reaches the maximum size or the maximum iteration is done, then it is going to return our ACC list. Else, now watch closely. First is we need to get the index, val idx, that is the index. So it will be the ACC list dot length. So whatever the length of our Sudoku what we have implemented will be the index for which we are going to mark it, because it's going to start from 0. So length will be always ahead of the index that we are going to see. So whatever we have, length minus 1 is already implemented, already we have it, and length is the value that we are going to add in. All right. Now if that value suits in, if not, then we are going to backtrack it and again find the value for the index like we had discussed in our previous video. All right, so let's find the value for. So watch closely. So what I'm going to do here is I'm going to use my default Sudoku board, and I'm going to flatten it. All right, and I'm going to use split at the length of my accumulator till now. So this will give me the value, like the default Sudoku board will have all possible values for 81 records or 81 numbers, and out of which I want to split the value for which I have. Why I am doing this? Because if I iterate through my ACC list to find row and column like we said here, so suppose if we have the index value 8, so we don't have anything from 3 onwards till the end. In that case, if we are going to find all the column level values, it's going to throw index out of bound error. So we need to populate these value from the default so that we have something to trace, and then we will accordingly replace those values going ahead. All right, so let's do this activity. So we create the new sequence which is going to be ACC list plus plus the rest. All right, now Watch closely. Whatever constraints we have implemented, constraints, whatever constraints we have implemented, we will call now. So now it is going to be new sequence dot. First is we are going to get the value of get matrix. We get the row and column value idx, and we are going to append it new sequence dot. We have the box, so it is going to be idx. Now because there could be repetition of values, so we need to have the unique values. You can have a method around it to create it. I am using set to just make this all unique, remove the duplicates basically, to set. Alright, so this will eliminate all the duplicates. Now we are going to filter from the temp, so to fetch the new value. Alright, so let's fetch the new temp. New temp will be temp dot filter not, and filter constraints dot contains. Okay, this is a syntactic sugar from Scala. What it will do is, if I have to filter a sequence from another sequence, so this is what will be filtered out from the temp, and remaining is what we have, and we can fetch a random value out of it. So let's take a random value out of it. So let's take a head out of it. So let's say random head, which will be random dot shuffle. We are going to provide new temp, and then we are going to get the head option, because there is a possibility we run out of numbers, and we give a default value as -1. Now what we did here is we accumulated all the values till here based on the matrix and the box. What we did here is, we had seen when we randomize it, every time the head changes. So we randomized, we picked the head, and we are going to use that head to fill our Sudoku. So let's call the create Sudoku, and it is going to be temp comma acc list, and this is going to be random head. All right. So this is the first method that is going to create a Sudoku, but this Sudoku is going to create a solution with -1. So if I have to run this, let's try and run this and see whether we are getting some value or not. So let's provide a default. So this is the temp value will hold the information from which where we have to fetch the values, and this second value ACC, this can be nil. So let's make it nil. Now let's run this. So now we will get some value with -1. Alright, we are getting this error. Why we are getting this error? Let's check it out. We are getting this error of index out of bound because we are going till 9. It has to go till 8. Alright, let's run it again. Okay, we haven't printed it. Let's print it. Let's say well, uh, Sudoku is equal to, and let's print this Sudoku dot for each print ln. Now the expectation, it is going to print the values which will have some -1 in it. Alright, so we have lot of -1 in this. Okay, so what we need to do is again same thing. So let's do this grouped by Sudoku grid dot fold left. Again it is going to be sequence of int, or we don't need it, we can directly print, because eventually we are going to print like this. So let's cut it out from here, paste it here, and we don't need this, we don't need this. Now it will be more in a presentable manner. Let's see how it looks like. Alright, so we see there are some minus 1 here, but we don't need a solution with a minus 1. So here our backtracking rule will actually come in play. Whatever constants we defined and the minimum value selection we defined, that will come in picture. So we have to find a solution where we don't have minus 1. So let's implement that here. So what we are going to do is dev generate Sudoku board. Alright, again it's going to be a recursive function. Now it will take a sequence. So it is again sequence, it is going to be sequence of int. Alright, which we can default to nil, or we can give any random value, or let's keep it like this, which will return a sequence of int. That is our Sudoku. So what we are going to do, what we are going to call this val Sudoku, which will be, we will create Sudoku with the default, and we can give a sequence which will be this sequence. What will be this sequence is, say you want to have, if we can already we have already generated this random value, right? But this will not make much of a difference if we don't find any solution with respect to this randomized sequence, then it is going to change. But there is a possibility in that if we have that randomized sequence and if we find a combination to that, then definitely it will have a better time complexity. But that is just we have to see. All right, if Sudoku contains minus 1, then we just repeat this process. Generate Sudoku board with sequence of random dot next int, and we provide the Sudoku grid, and we add a further one more value because we don't need 0, right? All right, and let's put it as minus 1. Okay, all right, else Sudoku. Okay, so we have completed this Sudoku board. Let's implement this Sudoku board and see whether we are going to get this value or not. We can give a value as nil, and same thing, we just copy this grouped by for each println and put it here. Let's add a println to identify this is our Sudoku board. Let's comment this out for time being. Alright, fingers crossed. Let's see whether we are going to achieve this Sudoku or not. Alright, so as we see, this is the implementation of Sudoku. All the columns and rows are unique. We have 9 value in each box, and this solution was pretty fast. So now this time complexity will vary based on this selection, and because we have randomized our selection, so every time we are going to get a different Sudoku. Alright, let's run this again, and we will see a different set of values altogether. Yes, as you see, run it again. Alright, so we are going to see different set of values. See, it has changed. Alright, so this completes the implementation. And one more thing, if you want to pass any other value rather than nil, like you want to pass sequence of 4 comma 5, this is also accepted. Let's run it, but it is going to change. You cannot see 4 and 5 at the beginning. The reason is if it doesn't find a solution, it will reiterate. Similarly, you can pass b, which we created initially as our randomized value, and we can run it. But again, the solution is unpredictable and it will give you a Sudoku but not what you have expected earlier. Alright, so this completes the implementation of Sudoku. If you enjoyed this video, please like and subscribe and watch out for my next video. Thank you.